Okay, let's dive into something really fundamental. If you ever touch a UNIX or Linux system, the shell.
Mm-hmm.
Think of it like this. The computer's brain is inside, right? The shell. That's your keyboard and screen, your way to, talk to it directly using text.
That's a great way to put it. It's the text-based user interface. And what's pretty cool, as the source points out, is that you actually have choices.
Choices.
Yeah, lots of different shells, but switching them is, the source says, as easy as changing hats.
Huh. A whole wardrobe of command line hats.
Okay, but today we're picking one, a really popular one,
Hmm.
the Bourne Again Shell, Bash.
Bash, exactly. The source calls it a modern general-purpose shell. And, it's everywhere now.
So it didn't just appear out of nowhere.
Oh, no, definitely not. It built on the original Bourne shell, that's sh, and it pulled in features from the C shell, crate. It even took some ideas from the corn shell, KS, which was commercial back then, but Bash itself, free. That was a big deal. It mixes the good bits of the old ones and adds its own stuff. Right. So our mission for this deep dive, using only the material you shared, is to really unpack Bash.
Mm-hmm.
We want to look at its key features, understand where its power lies, both as that everyday interactive tool and as a way to automate things, a programming environment.
Yeah, extract the real useful nuggets for you.
Yeah.
Give you that shortcut to understanding this essential tool.
And the source material seems to approach this logically, right? Interactive use first, then making it your own, then the scripting side.
Exactly. Interact, customize, automate. Makes sense.
Yeah.
You learn by doing,
Yeah.
then you tweak it, then you make it do the work for you.
Okay, let's start with that interactive experience. Making life on the command line easier. The source mentions command line editing as a big draw for Bash.
Oh, huge. Compared to the original Bourne shell, Oosh, which had like none. The C shell had history, but Bash gives you full-on editing.
Right on the line you're typing?
Yep. And there are two main modes, according to the source, V and Emacs.
And it recommends Emacs mode for beginners. Why is that?
Mainly because it's all control keys. You don't have that Vi concept of switching between command mode and insert mode,
Oh, okay.
which can be a bit weird if you haven't used Vi before. Emacs mode can feel, a bit more straightforward initially.
Makes sense. And there are useful commands mentioned, like moving word by word, deleting stuff, changing case. Oh, and CTRL-V.
Yeah, CTRL-V is handy. It lets you type a special character like maybe a tab or even a control character literally without the shell trying to interpret it immediately.
Gotcha. Okay, what else makes interactive use better? History.
Command history. Absolutely. Bash remembers commands you've typed. And the main tool for this, mentioned in the source, is FC.
FC fix command?
Yeah, pretty much. You can do FCLRL to list history,
Okay.
FETEL for the last 10,
Right.
FCL string to find recent commands starting with string.
Right.
But the real power move is FCE editor. It opens your history, or a chunk of it, in your favorite text editor.
Whoa.
Yeah. Make complex changes, save, exit, and Bash runs the edit command. It's fantastic for building up something tricky.
That is cool. Beats retyping. And then there's the quicker way, with the exclamation mark, history expansion.
Right. For the last command, bang, bang.
Everyone learns that one pretty quick.
Uh-huh. And string reruns the most recent commands starting with string.
And you can pick bits out of those commands. Word designators.
Exactly. Like 0.0 for just the command part, dollars to the last argument for all arguments. So if you ran SIP file 1, file 2, then Bet would give you file 1.
Okay, I see. So 0.0 gets the command, the first arg, dot the last, saves typing arguments again.
Precisely. It takes a little getting used to, but it's a huge time saver once it clicks.
Speaking of saving typing, TB completion. That feels like magic when you first see it.
It really does. Press T, and Bash tries to finish what you're typing. File names, commands, even variables if they start with a $, usernames after, host names after @
So not just for files, like lgute becomes els user.
Yeah, but also, say, echo tab might complete to echo path. It knows the context. If there's more than one possibility, pressing TB again usually lists them. The source mentions ESC. Does that too.
Okay, and it prioritizes commands over file names.
Usually, yeah. But ESC forces it to complete only file names, which can be useful sometimes. And there's even programmable completion, though that's more advanced stuff.
Right. Okay, basic navigation, working directory.
Simple idea. It's just where you are in the file system hierarchy at any moment. Your current directory, usually start in your home directory.
And paths can be absolute or relative.
Yep. Absolute paths start right from the root. with like Homestar documents.
Yeah.
Relative paths start from where you are now.
So if I'm in home user and I want home user documents report.txt, I can just use the relative path documents report.txt.
Exactly. And you use relative paths way more often. Like the example ilpattern 2time assumes hatter is a subdirectory of your current location.
Makes sense. Let's talk control keys. CTRLC, the panic button.
Huh. Yeah, pretty much. Sends an interrupt signal. Stops most runaway commands. If that doesn't work, the source says try CTRL. It's a quit signal, a bit more forceful. But try CTRLC first.
Okay, CTRLD.
End of input. Like when you're using mail or cat without a file name. Typing CTRLD on a new line tells the program, okay, I'm done sending input.
Got it. And CTRLS, CTRLQ, obsolete.
Mostly, yeah. Old flow control.
Yeah.
Sometimes CTRLS accidentally freezes your terminal output. If that happens, CTRLQ might unfreeze it. Good to know. But you wouldn't use them on purpose now.
Right. Now, handling special characters. Quoting seems crucial.
Absolute vital.
Mm-hmm.
The shell gives special meanings to characters like stew or space. Quoting tells the shell, hey, treat this character literally.
And single quotes are the strongest.
Yep. Single quotes strip all special meaning from everything inside. The example echo 235 is a valid inequality. Prints exactly that. No wildcard expansion, no redirection.
Double quotes.
They're weaker. They remove most special meanings, but crucially, variable expansion and command substitution like D still happen inside double quotes.
That's a huge difference. Echo home shows my home directory path.
Right.
But echo home just prints the literal string home.
Exactly. That distinction is super important. And then there's the backslash.
Just escapes one character.
Yeah. Removes the special meaning of the single character immediately following it. Often used to put a quote inside a string that uses the same kind of quote, like she said hi.
Okay, that covers a lot of the interactive basics. How
Yeah.
about customizing the environment? Startup files.
Right. Bash reads configuration files when it starts up. They live in your home directory. The main one for login shells is .bash profile.
Login shells, like when I first connect via SSH.
Exactly. If bash profile isn't there, bash looks for .bash login, then .profile for compatibility.
What about shells I start after I'm logged in, like opening a new terminal window?
Those are usually non-login interactive shells. They read, that's right.
Ugh, but yeah, sure. I've edited that one before. And bash logout.
That one runs when a login shell exits. Good for cleanup tasks, maybe deleting temp files or logging something.
So if I change my bash shard, add an alias or something, how do I get the current shell to see that change without logging out and back in?
Use the source command .source.bashrc. It reads the file and executes the commands right there in your current shell session.
Okay, useful. And the source mentions sourcing.basharc from .bash profile.
Yeah, that's a very common trick. It ensures that settings you put in Basharc, like aliases or functions, are available in both your login shells and any subsequent shells you start. Keeps things consistent.
Makes sense. Okay, let's shift gears into the really powerful stuff. Shell programming, scripts and functions.
This is where you automate things. Shell scripts are just files with commands in them. Functions are basically named blocks of commands stored in the shell's memory.
How do you run a script? The source mentions two ways.
Right. You can use source script name. We just talked about. Source it runs the script's commands in your current shell. Any variables set or directories changed by the script affect your current session.
And the other way, just typing the script's name, like .myscript.
Correct. When you do that, Bash typically runs the script in a subshell.
A subshell, like a separate copy.
Exactly. A child process. It inherits the environment, but changes it makes usually don't affect the parent shell you ran it from. To run it by name, the script needs execute permission, schmold plus X, and Bash needs to find it.
Either in the path or by giving the path like S. Got it. So source affects this shell, running by name runs in a new shell.
That's the main difference, yeah. Functions, by the way, always run in the current shell, but they get their own local copies of arguments.
Arguments. How do scripts and functions get those?
Through positional parameters. $1 is the first argument, $2 the second, and so on. If you have more than 9, you need curly braces, like $10 for the 10th.
Okay. And dollars represent all of them.
Yes, but they behave differently, especially inside double quotes. This is a classic tricky point.
Tell me more.
Ouch treats all the arguments as a single word, joined by the first character of the IFS variable, usually a space.
Okay, one big string.
Right. But Dalet expands each argument into a separate, individually quoted word. If you have an argument with spaces in it, like some file name, Dalet preserves it as one argument. I would split it.
So dollop is usually safer if you're looping through arguments.
Almost always, yes. Especially in for loops.
Got it. Let's talk shell variables. Named places to store, mostly strings.
Mostly strings, yeah. Though bash can do integers and arrays too. You get the value with varnard or more generally.
And environment variables, usually uppercase.
Conventionally, yeah. Like
Okay.
path, home, term. The key thing is they get passed down to child processes, programs your script runs. You mark a variable for export using the export command.
The source mentions declare for setting variable attributes.
Right, declare is pretty versatile. Declare my makes it an integer. Declare mar makes it read only. Read only is just a shorthand for that. Declare my makes it an array. Declare mako is the same as export. And unset removes a variable.
Okay. Now, this var name syntax, it's not just for getting the value. There are operators.
Oh yeah, this is where shell scripting gets really handy. Variable substitution operators. They let you handle default values, check for existence, and more.
Like var name dash word.
That's a common one. It means use the value of var name if it's set and not empty. Otherwise, use word. Importantly, it doesn't change var name.
Just uses word as a fallback for that specific expansion.
Exactly. Now, var name word is similar, but if var name is unset or null, it assigns word to var name and uses that value. You can't use this one on positional parameters like $1, though.
Okay, sets a default if needed. What about var name dot message?
That one's for error checking. If var name is unset or null, it prints an error message using message to standard error and exits the script. Super useful for required arguments or variables.
Definitely. And dem are in plus word. Kind of the opposite.
Sort of. It uses word if var name is set and non-null. Otherwise, it results in nothing. No. Useful in some specific logic scenarios.
There's also substring stuff. Demrm.offset.length.
Yep, substring expansion. Pull out a piece of the string starting at offset 0 based for length characters. You can even use a negative offset to count from the end.
Cool. And then pattern matching operators. Inside the braces, too.
Yes. These are great for string manipulation, especially paths. Hashtag and hashtag remove prefixes from the beginning. Percent and percent remove suffixes from the end.
Single hashtag or percent removes the shortest match. Double hashtag to get or percent removes the longest.
You got it. And the classic example is getting a file name from a full path.
The base name thing.
Right. If path name holds home user my report.txt, then path name hashtag uses the hashtag tech pattern. Longest match from the beginning is home user me. Remove that.
And you're left with report.txt.
Exactly. It does the job of the external base name command, but it's faster because it's built into the shell.
Yeah.
Using hashtag would only remove the first tick, which isn't usually what you want for a file name.
Got it. Longest prefix removal. Hashtag for base name.
Sure.
Okay. Arrays. Multiple values in one variable.
Yep. Declare with declare or just assign like my array 1, 2, 3, 4. Access elements with array index starting at index 0.
So my array is 1, my array null is 3, 4.
Correct. And like positional parameters, array at and array give you all elements behaving differently in double quotes. Array at is usually the one you want.
Okay. And integers. Bash isn't just strings.
Nope. Declare I makes minum an integer variable. You do arithmetic using the syntax.
Right.
Declare minum by 5. Declare minum by 10. Result. Now result holds 50. Notice you don't need all variables inside the...
Okay. And that calculation works even inside double quotes.
Yep. And you can specify bases too, like echo 16 tag ff, prints 255.
Hexadecimal.
Go.
Cool. Okay. Variables store data. How do we make scripts make decisions or repeat actions? Flow control.
The absolute key concept here is the exit status of commands.
0 for success, non-zero for failure.
That's the convention. Bash's flow control constructs look at the exit status of the last command run to decide what to do next.
Like the if statement.
Exactly. If command then phi. The then part runs only if command exits with status 0. You can add else and elif, else if.
And for loops.
For var in list, don't then, it iterates through the items in list, assigning each one to var. Often used for arguments, for argons at, or file names for filein.txt. The source shows looping through path directories.
Then while and until.
While command,
As well.
do done loops as long as command succeeds, exit 0 until command do none loops as long as command fails, non-zero.
And case.
Case word and pattern, command throw pan. Pattern 2 commands JUAS. It matches word against different patterns, good for multiple choice logic. And select is mentioned for making simple menus.
How do we perform tests for if or while, like checking if a file exists?
Using the test command, or more commonly its bracketed forms, or
Single or double brackets?
double brackets are generally preferred in modern bash. They're a built-in keyword, less finicky about quoting and word splitting than single brackets, which is actually an alias for the test command.
Okay, so error is usually better. What kind of tests can go inside?
Lots. File tests are common. naf file, is it a regular file? nashadir, directory.hepath, does it exist? Mash file, readable.mash x file, executable, nash file, size greater than 0, so not empty. These are vital for writing scripts that don't fail unexpectedly.
Makes sense. Check before you leap. What about strings?
String 1 and string 2, or string 1 equals string 2 for equality, string 1, string 2 for inequality. Nash D string is true if the string is empty, 0 length. Nash is in string if it's not empty. Nash are on length.
And numbers.
Use specific operators inside Nash EQ equal, now did net not equal, net L less or equal, Nash GT greater than, Nash is greater or equal, so toucan Nash GT 10.
Okay, Nash EQ, Nash GT, etc. for numbers, or DA for strings. Can you combine tests?
Yep, inside that you can use N and for logical AND or for logical OR, and will unir a 1 by style and or a par file.
Check if it's a file AND readable.
Got it.
The source mentioned putting arithmetic inside too.
You can, yeah.
Okay.
The expression is true if the expression evaluates to non-zero, false if 0.
Yeah.
But it's usually clearer to use the integer comparison operators like AQ-nay.
Right. Okay, one more scripting thing. Handling command line options like ABU or a Kia F file name. The source mentions gettops.
Gettops is the standard portable way to parse options in shell scripts. It's a built-in...
How does it work, basically?
You typically use it in a while loop, while gettops vf.o, opt, db, do. The string vf.o defines the valid options. V and F are simple flags F and O. Expect an argument because of the colon.
Okay.
Inside the loop, gettops puts the option character it found, like V or O, into the variable named opt, or whatever name you provide. If the option needs an argument, like F file or O output, that argument gets put into the special variable optarg.
Opt.
And another variable, optd, keeps track of the index of the next argument to be processed. You usually use shift after the loop to remove all the processed options and their arguments, leaving only the non-option arguments, like input file names, in a del.
Got it. It handles the parsing logic for you. Okay, let's talk input, output, and processes. Standard I/O.
The 3 standard channels. Standard input, file descriptor 0, usually keyboard. Standard output, descriptor 1, usually screen. Standard error, descriptor 2, usually screen.
And redirection changes those defaults.
Exactly. File redirects standard input from file. File sends standard output to file, overwriting. File appends standard output. File forces overwrite even if you have no clobber set.
Can you redirect just errors?
Yep. 2 error log redirects standard error descriptor 2 to error log, and a common shortcut is an output anders.log to send both standard output and standard error to the same file.
Handy. And closing.
An N closes output descriptor N, and N closes input descriptor N. Less common, but sometimes needed.
Pipes. The symbol. Core. UNIX idea.
Totally. Connects a standard output of the command on the left to the standard input of the command on the right, like ls-l grep.txt finds text files. The source uses diff file1, file2 more.
Sends the diff output to the pager more. Simple, powerful. Here, documents.
Lets you embed multi-line input for a command directly in your script. You provide delimiter word, like cat eof.lines.eof. Everything between the EOF lines is fed as standard input to cat.
Useful for embedding config snippets or messages. How about getting input from the user in a script?
The read command, read varname, reads a line from standard input and puts it in varname.
Useful options.
Prompt message displays a prompt before waiting. Dash R reads raw input. It doesn't interpret backslashes, which is usually what you want when reading user input.
Okay, control the output format.
Right.
Int versus echo.
Echo is simple, usually adds a new line. Print is more precise. It doesn't add a new line unless you tell it to.
And it uses format specifiers.
Right. Printf name, percent age, percent aim name age, percent for string, percent E for integer. You can control width, alignment. Printf percent 10 16 integer. Hello prints hello, left aligned in a 10-character field.
Much more control than echo. Now, evil. Sounds potent. Processes the command line twice.
It is potent and needs care. Evil takes its arguments, constructs a command string, and then tells the shell to parse and execute that string as if you typed it.
So you can build commands dynamically.
Exactly. If you have command parts in variables, Evil can put them together and run the result. Evil-ACK is sometimes used to reparse the script's arguments. Use it carefully, as it can have security implications if used with untrusted input.
Good warning. Okay, process handling, multitasking.
UNIX Linux lets you run multiple things at once. Putting it at the end of a command runs it in the background.
The shell gives you the prompt back immediately.
Right. We mentioned subshells for scripts run by name and command substitutions. They run in separate processes.
Job control, CTRL-Z.
Yep. Borrowed from tree. CTRL-Z suspends the current foreground job, puts it in the background, stopped. You can then manage it with commands like big E, resume in background, FG, resume in foreground, jobs, list jobs.
How do I see all processes, not just my background jobs?
The big C's command shows process IDs, PIDs, terminal, status, command name. Lots of options to control the format.
And kill. Doesn't always mean kill, right?
Right. Kill sends a signal to a process identified by PID or job number %. The default signal is terminate, which asks the process nicely to exit. But you can send others, like HUP, hang up, or kill, the forceful one.
Programs can catch signals with
All-
trap.
Yes,
Yeah.
trap command or run signal, like trab echo, caught ETRLC, cleaning up, EE, Steve, Pam, temp, tellus, exit, INT. Catches the interrupt signal, SIGINT, from CTRLEC, runs cleanup, then exits.
Special variable.
PID of the current shell, super useful for creating unique temporary file names, as shown in that trap example. PCAM prevents clashes if the script runs multiple times.
And the
PID of the last command put into the background.
The source mentions parallelization briefly.
Just that on multi-CPU machines, background jobs can potentially run truly in parallel, speeding things up if you have tasks that can run independently.
Okay, what if scripts go wrong? Debugging.
Basic tools are built in. Setnaxx is the workhorse.
Nice trick.
Yeah. It makes the shell print each command before it executes it. After variable substitutions and expansions, you see exactly what's being run.
And setnexv.
Verbose mode. Prints input lines as the shell reads them before any processing. Less common than setmassx, but sometimes useful. You turn them off with set plus x and set plus v.
What about that trap ERR thing?
Another debugging technique,
Right.
trap error handler function, ER. The error handler function will run whenever a simple command in your script exits with a non-zero status fails.
And inside that handler.
You can use $ to see the exit status of the failed command, and lino to see which line number in the script it happened on. Great for pinpointing errors. The source notes you might need setDAC for the trap to work inside functions or subshells. And of course, there are dedicated debuggers like BashB.
Good to know. Briefly, environment portability. Stuff varies between Bash versions.
It can, yeah. Newer versions add features. Building from source, configure make, lets you get the latest, but usually needs admin rights. Also, scripts using Bash-specific features might not work on systems with older Bash or different shells like plain Ash. Things like arrays aren't universal.
Privileged mode.
SRP.
Security thing, mainly for suid scripts, which run as a different user. SHP stops Bash from reading user config files like bash arc, which could be insecure in that context. But the source strongly warns against writing suid shell scripts anyway. Too risky.
Yeah. Okay, finally, some good practices.
Follow standard conventions. Input files as arguments. Use options like .show file name for output. And try not to rely on obscure environment variables being set. Pass necessary info as arguments to make your script more self-contained and reliable.
Wow, okay, that was a lot. We went from basic interaction, editing, history, completion, all the way through scripting with variables logic, I/O, process control, even debugging. Bash really is incredibly flexible. It's that fundamental layer for interacting with and controlling UNIX Linux systems. It's both a user interface and a pretty capable programming language.
Yeah, thinking about, the string manipulation with leal, building commands with evil, testing conditions with evil, it really opens things up.
Which leads to a thought. Thinking about everything Bash can do, particularly automating sequences of commands, checking conditions, handling data. What's some repetitive digital task you do? Something maybe tedious. Could you start sketching out how a simple Bash script might handle that? How might knowing these building blocks, variables, loops, tests, redirection, change how you approach solving problems or just getting things done in your computer?
That's a great question to leave us with. How can this tool change your perspective? Something to definitely think about.
Indeed.